Thank you for joining 4C Marketplace for our webinar series. Our speaker today will be Ward Swanson of Barr Engineering, talking about You've Got PFAS, how to prepare, dispose, and respond. If during the course of the webinar you have a question, on the upper right-hand side of your screen, there's a little show conversation icon. If you click on that icon, there will be a type new message appear in the lower right-hand corner. And that is where you type your question. And at the end of the webinar, I will ask Ward those questions. And if I don't get the question quite right, feel free to hop on and add clarity or follow up to the question based off of the answer. And with that, if there is something that you feel like really should be addressed right then you can also raise your hand. Next to the conversation icon, there's a raise my hand icon. Okay, with that, I'll turn it over to Ward Swanson of Barr Engineering. Thank you very much, Ward. Take it away.
Thanks. Thanks to all for coming. As Steve said, my name is Ward Swanson. I've been at Barr for over 20 years, and I've been working with PFAS for probably around 18 of those years, when Barr and myself were hired by the companies that manufacture these compounds to look at their fate and transport in the environment. Since then, I've worked with a lot of different industries on these compounds, including the fuels industry, multiple pipeline terminals, and refineries. As Steve said, my talk is a lot about strategy. I'm not necessarily going to dive into the basics, but I will cover some properties just to make sure everyone's on the same page a little bit. I've given talks like this, and I try to update them every chance I get. So hopefully I will get at some of what you guys want to hear about. I do have some new technologies that we're looking at included in this, as well as some of the, I'll say, new things clients of ours are trying and doing related to these compounds. So with that, we'll talk about some preparation steps before you do any kind of sampling, evaluating your situation, and some things people have found helpful to think about and look at when you're looking at these removal. To let you know, I did a poll at another one of the talks that I gave, and about to the fuels industry, and about 40% of the group on that particular talk hadn't even started addressing it yet. So hopefully some of these evaluation steps will be helpful to some of you. We'll talk about disposal, the options and actions. If you've been following this, there's not a lot of change, but there are some nuances that I'll talk about, including some late breaking stuff. Then evaluating your response to what you have and how you're going to go about it. And then remediation and regulatory strategy. The development of those two things has become very important. Probably always was, but it's pretty important. And then I looked at, people have been asking me what are the top trends I see coming, and the biggest one I see is in the regulation side, and I'll discuss that a little bit as well, along with some of the other trends at the end. So to get us started, just a quick overview of the PFAS properties. As many of you said and know, that these are resistant to biodegradation, at least to the terminal compounds, which are the C8 straight chains and below. Anything larger than that will show some biodegradation, but once you get to those C8 chains, the PFOA and PFOS compounds, the biodegradation is pretty minimal. They're completely miscible in water, particularly at low levels. So like a lot of environmental contaminants, they're really easy to mix into water and really hard to get out of it. It's a key property and one of the biggest troublesome parts of it. They have some affinity for organic carbon, which we can use to help us remove those from water. So organic carbon related treatment, which we'll talk about, but it also can be a problem in that some of particularly the ones with longer trains will adhere to some of the organic carbon in soils and biosolids and slowly degrade and or release over time, which can give you this long running ghost type release. They're usually found in a mixture. You don't find one of these by itself. That's because of the way they were either formulated or manufactured. One of the main manufacturing processes involved a lot of impurities in it, so it would produce 80% of the compound they were looking for, but had 20% of let's call them other compounds, impurities. But they became these other things that are usually found in these mixtures. And they are semi-volatile, so they will go up in the air, sometimes at very low temperatures. They like to stay with water, so if you had any process that was heated or has any kind of water vapor coming off of it, the PFAS will stay typically in that water vapor, so they can create a deposition problem as well for some industries. Not so much in the fuels industry, though, as you know, as the biggest source in the fuels industry is the firefighting foam, AFFF, Class B foams. They're very good products. They're excellent at putting out hot fires and fires involving fuels. The PFAS enables the formation of very small layers, really thin layers that will remove the oxygen from the situation, thus putting out the fires. They've saved countless lives over time. But because of that, most of them also have PFOS in particular, but other sulfonated PFAS in them. So most places that have fuel in production have at least a signature of some of these things. So when I tell people about preparing for it, what do you look for? Evaluate your uses. These have been used for other things beyond just putting out fires, like vapor suppression. So if there's been trenching, this sometimes gets used for that. Evaluate your conveyances. Is it stored in fire suppression systems, and how is it stored? Look at current, but don't forget about historical and reviewing SDSs. But we found a lot of value interviewing experienced staff. Where do we used to do fire training? Where have there been fires? What did we do with the debris from that? Old landfills, that some of your facilities may have landfills. It's another place to get on your radar as you're looking for where this stuff might be. And one of the last moves you probably should make is looking at collecting samples, and I'll talk more about that as well. And then evaluating new regulations. There's been a lot of changes in the regulations. They continuously are being upgraded and potentially downgraded, but there's a lot of handling and reporting requirements now, depending on the geography you're in. States are requiring reporting when these are released, and different types of cleanups when you have to use this. Some have forbidden training with them, but also even handling. A lot of states are tracking these. So as you're preparing, looking for where potentially your issues are, those are things to keep in mind. Another thing to remember or think about is biosolids from your processes. If you have a lot of organic carbon in a biosolid and you've had fire training water go through your wastewater treatment plant, that also can be a potential longer term source. And what did you do with those biosolids? Were they put in a landfill? Were they destroyed in the coker? It's another thing to get on your radar. And then other costs to think about, system purging. If you decide to switch out to a fluorine-free foam or a different product, because these things are looked for in parts per trillion levels, removing the residuals is a deliberate action you have to take. There are contractors out there who have experience cleaning out these systems, but it's a little more than a single rinse, as I've been in my experience. So it's something to think about, additional costs. Also equipment requirements. If you switch to a fluorine-free foam, some of them don't use the same types of pumps. These are other costs you have to think about and evaluate, as well as, potentially some of your old equipment could have low levels of PFAS attached to it for a long time. And then the sampling and testing involved with that, just proving that you don't have it in your system anymore, is going to add additional costs and take a little more time. Other things, if you're going to continue to use these foams, because again, they do work, how are you going to modify your emergency use procedures? As I said, some localities now require immediate cleanups, scraping up of foam, making sure it doesn't get into surface water, that kind of thing. It's coming up a lot in acquisition and divestment. So if you are in the purchasing mode, are you looking for this as another contaminant when you do your due diligence, and when you're selling maybe the same thing, just to document the conditions of your property before you would divest it, so that you can't be blamed for things in the future. We're getting a lot of issues with this with recently sold things, but not recent enough that they've thought about these things before they sold it. The other thing is portfolio management. A lot of our clients have multiple either terminals or along pipelines or refineries. How do they manage the risk differently and look at them all and try to address them? And we talk about a risk evaluation matrix, which I'll bring up a little bit more. So as you're thinking about what you're going to be doing, these are all things to be going through your mind as you prepare to deal with it. Disposal options. Unfortunately, as I said, there hasn't been a lot of movement in this space for those looking for that. It has not been designated as a hazardous substance at the federal level anyway yet, but it does look like that is going to be in the works. So because of that, you can still go to your normal landfill options if they will take it. A lot of Subtitle D landfills, due to permitting requirements, aren't taking PFAS related waste anymore. Most Subtitle Cs are. They do a better job at managing their leachate, typically through incineration or other ways. And then an incineration was always the one way to get rid of it, because if at the right temperature, these things can be broken down into their base materials. There's been a lot of opposition in the most levels of government and even in the legislature about trying to stop incineration. But they believe it doesn't completely destroy the compounds, or it just reforms them into something else. A couple of articles here, the EPA was going to do a study on PFAS compounds in incineration. They backed out of that study. Then they did not perform it. I will say also that they released this interim guidance on destroying and disposing of PFAS. It was statutorily required that they do that in 2020 by the National Defense Act in 2019. And if you read it, it's not really so much of a guidance as a list of everything that you could do to dispose of it. If you're not up on the disposal methods, it's actually not a bad read for that. A couple of things that people are doing more leave it on site. That is actually in this guidance. Can you keep it on site and either cover it so there is minimal leaching, at least in over the short term, being a few years until the technology gets better? Or is there a site you're already treating with PFAS where they would allow you to move it? So even if there is some leaching, you're capturing, it's within the capture zone. So those are some things that are happening. Also, just recently, this week actually, there was a incident at a ceramics kiln in New York where environmental groups, that was destroying AFFF for the military, environmental groups went around and sampled and claimed they were finding elevated levels of PFAS. The New York Department of Conservation just this week released their study of it and found they felt it was pretty much just background levels. So that's out there for you to look at as well. So there is some evidence that the incineration still is getting the job done the way that's intended to. Okay, so you're looking at it and you're looking at other responses. I talked about evaluating risks. As you look at a portfolio or even your individual sites, what are going to drive action or should drive response? The biggest thing that's been driving this, if you've been following it, has been stakeholder reaction. People are, depending on the geography you're in, some state regulators are okay with it or okay with sticking to certain levels that the EPA came up with, and the population is not as interested, but then others are completely the opposite. So depending where you are, that could be a big driver for as you look at your risk factors. Obviously, migration pathways, drinking water is the most sensitive issue out there. If people find it in their drinking water, it rises to the top. So as people look at their portfolios, that's another big one. Where is your groundwater going? Where are the potential PFAS containing waters going? Local regulations, as I alluded to earlier, they've been changing pretty fast, and some of them are still in their infancy and others are more refined. So depending on where they're at with that. And then I added your local PFAS plan, and I threw that out there because there's a lot of states that their first response has been, we're developing a plan to what we're going to do. Some call it a blueprint, some call it other things, but different states are beginning to use these plans to answer the public how they're going to address it. But it's good to be familiar with what those are in your locale, so you can be up on where they're going to be going next. And I will talk about elements of those plans when I give a little bit of a regulatory update. Okay, so responses, looking at different responses to the problem. If you have PFAS, data collection. This is an old slide, but it still matters because you really should begin with the end in mind. Develop some objectives for why you're going to collect samples, what you're going to use the data for. Be pretty clear on those objectives. There's a lot of regulatory agencies in particular that are looking for a lot of data, but the question you should always be asking is, what are you going to use the data for? Consider doing it with legal advice. Why are we collecting it? Why should we be collecting it? And experience matters. There is cross-contamination with these contaminants is real, but also I've talked to a lot of clients and they've really valued a consistent team, both on the legal side, the operations side. You get people educated on what these issues are one time and you stick through the whole of the project. It really makes a difference and makes things go a lot smoother. So experience could be they already have experience working with these things, or that they have been working on this particular project and keeping the team together has made things go a lot smoother as the regulations change, sometimes right in the middle of your project. So remediation strategy. Let's talk a bit about potential actions that you can do. The source control, as I said, the newest thing that people are talking more about are on-site covers. Can you collect up a soil and cover it so it's really not getting any rainwater? It might take a little more work than in the past, just putting under asphalt, but it's something to definitely think about, or putting it on a site with active remediation, as I said, if you are going to dig it up. In situ source control still is more about blocking it from moving. So there is slurry walls, of course, and then managing the water behind that, but also things like injection of activated carbon can slow down the PFAS. It will adhere to that as it moves through the water column, but it slowly will release over time. But I've seen models, and we've looked at doing this on a particular site where it's predicted up to 10 years of freezing it in place, and that would help with the technology development. And ultimately, as I've talked about, this is a water treatment issue. It is a water issue, and I'll talk more about that. So the primary treatment technologies, the ones that are most accepted now in states, are absorption technologies. So they absorb the materials as they come through. So think of a sponge. You start with dry sponge, you pour water on it, and once the sponge is full, it won't take any more water. That's how these act. So the media has to be changed out. The two are granulated activated carbon, which is upper left, and then ion exchange resins, which is right next to it there. They either fit spatially or on active sites. They can be knocked off by shorter chains tend to break through first, which can be an issue. Back to your strategy. Are you trying to remove all PFAS or only certain compounds? If it's all PFAS, you'll be changing media more frequently than if it's just PFOA or PFOS, which are the main components of your firefighting foams. Other issues with these types of water treatment technologies are other things also will follow the sites. They will take up space and make your media not as effective. Things that are common in water, like iron, other total organic carbons. So if you have hydrocarbons mixed with it, they will compete with these sites. So that usually results in some sort of treatment pre-treatment before you have to treat for the PFAS, which also adds costs. Shown here is just a typical layout, a lead and lag vessel. Typically there's sampling on the influent, the midpoint, and the effluent, and when you see breakthrough in the midpoint, you look at changing out your media. There are some potential new treatment options out there that are developing. There's expanded options to move away really from granular activated carbon and ion exchange, as they are kind of expensive and they do have the flaws that I've talked about. Some of these are more in development and some of these are more in the pilot or actual implemented phase. One of them is Regenerable ion exchange. I think if you've seen anything from ECT2, you'll see information on this, where they actually can regenerate the resins right on site, and they come up with a brine, so a concentrated solution of PFAS. So you do still have a waste stream to treat, but it's a smaller one that maybe incineration makes more sense for. Then there's coming to the market, there's a lot of new absorption technologies that work better than granular activated carbon. They have less potential for fouling from more common constituents. We're working with one company in particular to test different matrices on that. So look for those in the near future. Another one that's big in Australia is foam fractionation. These compounds tend to be, as said, miscible in water, but they also really gravitate to the water and air interface, which tends to be foam. So some states are actually sampling foams on lakes and rivers to see if they are PFAS containing. So the way this works is it basically purges your water column, creates a foam, and then you harvest the foam, and it takes away a good percentage of the PFAS with it. So then again, you do have a concentrated waste stream. The downside of this is it doesn't get you to low parts per trillion, but it can take you from in orders of magnitude. It can take a lot of it off of it. So it could be a viable pre-treatment option, or depending on what your blending situation is, it could be a viable option. It's also doesn't have the problems with really difficult matrices, so it doesn't get interfered with as much as the traditional ion exchange and granular activated carbon. So we're looking at this technology for a few sites we're working on. And the biggest silver bullet, and this goes to the disposal thing, is different types of defluorination or destruction technologies. There are some catalytic related technologies that are working on this that show a lot of promise. I think they're even in getting the pilot stage. There are also things like plasma and other reactors that are breaking the carbon fluorine bond. Some of those are very energy intensive, so they're working on that. So but this avoids the incineration angle and the problems with that, and eventually makes these membranes or treatments that create brines more feasible, as they can take those concentrates and then break them down one step further. So that's what's out there, and some of those are in development stage, some of them are a little further along. So that's what we're keeping an eye on, and in some cases applying. So I talked a bit about regulatory strategy. This is becoming a bigger and bigger issue. Again, as I said, a lot of regulatory agencies are just developing their own rules, and they're not sure exactly where to go with them. And so one of the reactions is to ask for more data. And so a lot of them are wanting to look for more compounds, more samples, different places. And what we try to do early on is establish those boundaries with the regulatory agencies, since they're not sure exactly how far they want to go. Knowing what you're going to clean up to is kind of imperative. What compounds, what does clean mean? I mean, if I take samples here, here, and here, what is delineated? Is it 0 PFAS compounds? Is it below a certain level? Is it certain compounds? So setting those up is really important if you can, and then be deliberate when you're collecting those data based on those boundaries, based on your objectives, and then trying to stick to it. So I have a few sites where when we began the investigation and cleanup stages, there was a certain level of compounds and a certain number. Since then, the state regulations have evolved to add more and more, and it's been helpful in some cases to say we're just going to stick to our existing list. In other cases, they haven't allowed that. But trying to get those boundaries set up ahead of time is really a key as you're talking to regulators. In a lot of cases, they're very willing to help you out and do the same thing, get things figured out ahead of time, so we're not just continuously in some loop of gathering more and more data. So like I said earlier, I've been looking at trends, and people have been asking me the top 5 trends this year. I think some of the second and third places I will say is biosolids really seems to be a trend. A lot of states are looking at it. The issue there is wastewater treatment plants, virtually all of them have some level from commercial products or from some other industrial use in their biosolids, and how they're disposed of, if they are incinerated at low temperatures or roasted in some cases. The PFAS will get airborne and travel with the water vapor. If they are land spread, the PFAS can be uptaken by plants and then by animals. And so it's causing a bigger issue. So look for more information on biosolids or more issues with biosolids coming out. Also air issues. As I've said, there are multiple processes. It doesn't take much to put these things into the air. So some states are beginning to start looking at these issues. The other is NPDES regulation, but that kind of fits under what I think is the biggest trend, which will be regulatory trends, particularly at the federal level. We'll talk a bit about the states as well. With the results of the election, the new administration has a different approach to PFAS. The previous administration was moving forward with a number of initiatives, but the new administration, this was in their platform even before the election, that PFAS was going to be something that they took on. It does look like they're moving forward with that. One of the indicators is Michael Regan, Biden's pick to run EPA. He was actually just confirmed. I saw the news this morning, so I think it was yesterday, as the head of the EPA. He is from he was the head of the North Carolina Department of Environmental Quality. He actually took on CAMURs related to a PFAS compound called Gen X, a next generation of PFAS compounds, and held their feet to the fire around that chemical being present in the Cape Fear River. He's very well versed in what these compounds are and how they act. And I would suspect that you're going to see more action from the EPA federally related to this. And more evidence of that was actually things that were done right before the new administration took over. Some of this was statutory and some of it was the previous administration just trying to finish their initiatives. And one of them was the moving forward of the MCL, or the maximum contaminant regulatory determination, for PFOA and PFOS. So for those of you not familiar, this is a drinking water criteria, but a lot of states' other criteria are tied to it for groundwater and even in some cases soil. And that regulatory determination is moving forward. Since taking over, the Biden administration has reaffirmed that. So it's out for comments now, I believe, and then they'll begin looking at actual numbers to implement in replacement of the 70 parts per trillion health advisory levels that are currently out there federally. The other thing they're doing is they've updated the UCMR, which is the Uncontaminated Monitoring Rule. So they look at water systems across the country that serve over a certain number of people. It was 10,000. They've actually lowered that as part of this update, and they've added 23 different PFAS compounds to the list. So they will be looking in more places in drinking water and more chemicals. That'll raise more awareness, as these chemicals are out there in for a lot of different reasons, and it's undoubtedly they're going to be found in additional water systems. They've also put out what they call advance notice of a proposed rule, and that would be to declare PFOA and PFOS and potentially other PFAS compounds hazardous substances. And I brought up that earlier in the disposal discussion, because if this goes forward, it'll actually trigger Superfund rules, where a lot of states have their haz waste or hazardous substance designations tied to the federal, and that'll give states a funding mechanism under Superfund to begin cleanups and having responsible parties have to perform cleanups. So this is still an advance notice. I believe it's still out for comment. There was some speculation that the new administration would change this, would pull this back and just release a proposed rule. They haven't done that, and they've reaffirmed they're still taking comments on this. But that could be a significant piece of rulemaking that would affect how these compounds are handled. And the last thing the last administration did is they released a PFBS, which is a short chain PFAS compound toxicity assessment. PFBS has been used as a replacement for PFOS in a lot of different applications. There's also effluent guidelines being examined for the plastics industry, which is the beginning typically for how they would approach looking at other effluent guidelines federally. And there's a few other regulations that are going on. So again, some are statutory and some are not. So states, a lot of states, and I would say most, are at least addressing or looking at PFAS. These are some of the things that they're doing, looking at lower numerical standards, depending on the state you're in. Some are just looking at using the federal guidance, and some are using their own. A lot of them have gone down in the last year, and a lot more states are looking at moving through their state processes to establish numbers and potentially lower them. They're all looking for more compounds. The longest list I think I've seen is 40, but there may be longer by now. I mentioned biosolids. It's becoming an issue in dairy states in particular, that animals uptaking the PFAS compounds and discharging it in milk and other products you get from cattle. Discharge requirements, different states have already moved forward with some NPDES requirements. Some are specific to certain water bodies. Others are going to be more, look like they're going to be more global air impacts. And then almost, I won't say every state, but most states have done some data collection or began as part of their PFAS plan, looking at collecting data. And they start with the usual areas like airports, Department of Defense areas, landfills, and in some states, refineries and other places that have used AFFF are also on the list. So I'll sign off with some key takeaways. The regulation is still continuing to grow. At the federal level, it does look like it's going to be the most significant, definitely in the next 2 years. So take a look at what you're using, how you've used it, where you've maybe kept it, prioritize those risks. Don't underestimate the stakeholders in your area, and develop your strategies. So that is what I have for you today. So thank you for your attention, and I will take questions.
Thank you, Ward. Yes, we do have several questions. I'll try with the first, and again, John Kirby, I'll start with yours, and if I don't get it quite right or there's follow on, feel free to jump in. What options are there to fluorine firefighting foams, and what chemicals are in those materials?
Yeah, there's a lot of fluorine-free foams out there. A lot of them are actually hydrocarbon based, believe it or not. They use a different technology and more of an encapsulating than a covering. We've looked at, I think the last evaluation we looked at, we had over 30 or 40 different types. We tend to look at those, and if you're going to evaluate those, I would look to a few things like how much information they're willing to give you as a vendor. We've had some that wouldn't tell us anything, and others that were much more freer. Gives you a little more confidence that it truly is fluorine free. The other tricks are, they may say PFOS free, but it means to them less than a part per billion. We've seen that as a thing, so it still has PFOS in it, but still at levels they call below what their criteria are, but it might not be below what your action levels are. So those are some pitfalls to look at. But there's a Solberg product that people have used. I bring that up not to endorse it, just to, it's the only name I remember off the top of my head, but it's more of a hydrocarbon based, and it's long chain hydrocarbon, so it's not a typical flammable type substance, more of like a starch or cellulose type products.
Did that answer your question, John Kirby?
Yep. It also opened up some other questions. I see some popping up too. What is the toxicity of other compounds compared to PFAS? PFOA or PFOS. I don't know that you'd have all the answers to that, Ward, but just throwing
so
it out
in the replacement foams or in the hierarchy of PFAS compounds?
Well, we're talking about substitution, right? For non-fluorinated foams.
Yeah.
What? Yeah.
Go ahead.
Well, what are the risks? Are the toxicities and risks associated with substitution with the different chemicals? And then you kind of answered the question by saying we don't necessarily know what those compounds are. They may be given, what do you call it? But we don't know. They're not really defined as far as what the makeup is.
Yeah, they don't like to give away their formulation, but there are toxicity tests they have to do, I believe. The issue with the reason that AFFF and PFAS in general haven't been necessarily on the radar of toxicity, because they tend to bioaccumulate, so low levels become higher levels, which is why the regulatory levels are low. We were talking about this before, but these other types of compounds don't necessarily have those same attributes, but you never know what you're trading what for something else. These things tend to be more biodegradable, so they will break down, and you can get rid of them. So I'm talking in generalizations. I'm sure there's other places you can look to find out those toxicities. The biggest issue I hear from fire chiefs is they don't work as well, or they work differently. So you really have to make sure what you're getting is going to work for your facility. AFFF was always the gold standard. And so a lot of people bought it for places that maybe didn't necessarily need it and used it. But there are places that it still probably is the best product. So that's what I would worry about more than it's based on my experience. The other part, what are we substituting and what other thing are we getting? I think the devil's in the details, and I had to look into that. But I haven't seen a lot of problematic toxicity studies on the fluorine-free foams as of yet.
What about deep well injection for the aqueous material?
Yeah, I had anticipated that wouldn't be something that EPA would acknowledge as a useful remediation technique, just because these compounds don't break down ever. So even if we don't access that aquifer for 1,000 years, they may still be there. However, I say that, and it is in the EPA's assessment of technologies to dispose. So it's possible if you have the right conditions, they may entertain it. I don't know an example of one where that actually is happening right now, at least not intentionally. I think it's been happening for a while as other sites are, for other reasons, things are being deep well injected. I think it could be a viable technology if your regulatory authority is willing to let you do it. The problematic part is they don't break down.
Yes, the bioaccumulation is one of the bigger drivers for the AFFF.
Having the low toxicity numbers, because it doesn't shed from the body very fast.
Jimmy Bracker, I see you have a note there that says we have developed options to process a pure AFFF at our plant in Deer Park. You're more than welcome to type in your information there in the new message down below, and I'll reach out to you about setting up a separate webinar to discuss your process. Let's see, I'm sorry, I've got to scroll down here to get the last of them. One question, Ward, is the Satellitic's data. If Satellitic has this data, why are they spending a whole bunch of money sampling all over? Do the states just not want to access that Satellitic's data, or?
Maybe awareness. I don't know that. I don't know. I haven't seen that as out there a lot. So you would think it would be something that'd be useful to them. But I admit I haven't talked to the Satellites people in a while, so I don't know why it's not in widespread use.
Yeah. The resource for evaluating alternatives, is there a good resource out there for if there's 40 different alternatives to AFFF? Is there a resource available at all?
We've had to do it ourselves by looking at different vendors and then wading through it. I won't say there isn't a resource out there. Maybe some trade associations that have picked it up. I have seen some evidence of there's a firefighting foam coalition that has looked at it, I think. So there may be a few trade associations out there. Otherwise, it's legwork that we've done for clients. So consultants have done it. The piece, again, to be concerned about is the effectiveness. But I think there are, I haven't seen a one-stop shop place, but that doesn't mean there aren't a few options out there.
Maybe after the webinar, we'll put the address for that other coalition in there for folks if they would want to reference that. One other thing that you mentioned in your webinar was before you go sample, you need to have a team and a goal in mind. And I just wanted to give a very shameless plug for AFPM. There was an amazing presentation at AFPM, I believe a year or two ago, that talked about what you do and how you build a team of people to start the process, who should be on that team, who the stakeholders are. That was one of the best presentations I've seen on any subject, any time. It was a really, really amazing presentation. So a plug for AFPM and the environmental conference. I know that I saw that presentation, and it was I know this presentation covered the broader topics, but that more narrow topic of how you build a team, there's a lot of thought can go into that, and someone put a lot of thought in it and did a great presentation.
Yep.
So yeah, I would not rush into that haphazardly sampling, because that presentation really laid out the importance of thinking about all the stakeholders involved, getting those stakeholders engaged at the outset, and really keeping those stakeholders involved throughout the process.
And again, trying to keep everyone within the boundaries that you set up, because it's really easy as different compounds get added to state lists and different rules come out to drift. And if you're going to, which sometimes you have to, making it part of that deliberate process rather than just someone knee-jerking and doing something. Because we've seen that too, and that's been costly in a couple of cases.
Yeah. This isn't something that you want to go after willy-nilly, run and grab some samples and then send them to somebody and let them deal with the consequences. Yeah, it's must be a well thought out process, and think about from the beginning to the end and who the various stakeholders are, and get all of the stakeholders engaged from the outset. Okay, thank you very, very much, Ward, and thank you for all of the participants today.
I think I see a hand up.
Oh,
or I did see a hand up.
Oh, there it is. Ned, would you like to ask a question?
Yes, I'm curious. You talked about granulated activated carbon, and you also talked about resins to collect these compounds. It would seem to me that PFOS type compounds would be more likely extracted with resins. Is that the case?
Actually, the sulfonates stick better to both. The resins can be adapted to deal with the shorter chain compounds a little bit better than the carbon, because carbon's a natural product. At least in our experience, the first ones to go through are the shorter chains, so a PFBA at the acid form, at least on what we've seen in the data. But the advantage of resins is you can tailor if you have certain signature compounds that you want to reduce specifically. So they're really good at polishing in particular. We use a lot of combinations of carbon and ion exchange resins.
Okay, thank you.
That makes sense. Okay, well, thank you, Ward, and thank you for all of the participants today. And with that, it concludes the webinar. Again, this webinar will be posted on the 4C YouTube channel and will be posted on the 4C website and on a LinkedIn social media post by myself and most likely by Ward. Thank you all very much, and take care. Be safe.
Thank you.